Hi everyone. So the topic that I'm intending to cover today talk about retrieval augment generation. In term we call it RAG. So the topic that we'll be covering will talk about how RAG works, how it comes into picture, and when it is supposed to be used. Prior to that, we'll understand how this RAG, what is the gap that this RAG is trying to fill in. So we'll start with ChatGTP for example, for or any other model we can use. Now supposing we are using ChatGTP, and if we ask it a question, we'll get the response because it is already being trained the data, or it already got integration with the sources from where it's searching across the web for the response and give us the response that is very much in context and it's precise to our expected answer. However, if we go a step further and if we use ChatGTP or any other LLM model which intend to call or intend to gather data from some proprietary database or data sources that is not hosted publicly, so it's obvious like we'll not be able to fetch the data, or we'll fetch the data but that will be like not not something that is very precisely updated or would be something we are getting from the public domain. So this is one of the challenges that we face when we are trying to use the integration of the LLM with our in-house systems, proprietary data sources for illustration. Now how RAG comes into picture. So RAG is something we can visualize like a data source where we are saving the data in numerical representation called vectors, and in interchangeably we could use the term embedding database for same. So we have the native embedding models like SASI that's given by Python itself, or we have transform based embedding data models, and we have a lot of models that are specifically used for embedding. Or we can visualize any embedding model is something that used to save the data in n-dimensional space. We can visualize like n-dimensional space. If we see an example, if you see here, we see embedding database. So if you see the image, it's something like it will save the data in 3D in n-dimensional space. If you see here, probably I should, oh yeah, if you see here, you can visualize for one of the data. If we do the analogy from the relational database, it's like we have one row entry that has multiple columns, and we can say, okay, these different dots are representing the different features of that row. And based on that in n-dimensional space, we are able to say, okay, this is a particular or the entry that lies in this position. And going further, the embedding database or interchangeably I say the RAG that we're going to use will be saving the data in numerical representation in this n-dimensional space and would be used to retrieve the response based on the forthcoming user query. Now let's see here how the structure appears. If you see the flow goes like user will use the context to generate answers and will find relevant. If you see, basically the structure goes like this. We have multiple phases. So first of all, for illustration here, suppose I'm intending to save any PDF file that I don't want to search across using the search box using global search, because that needs a manual intervention after getting the response to figure out which one is the exact response and how reliable the response is. So the reliability doesn't come with the search global search option. As I've lately told that, like if we search across a conference, we'll not be sure like the response, how precisely that is what we are looking for, but that is something will not be the concern here in the RAG implementation, because it will give us the response based on the n-dimensional space. It will precisely point us to the response. Now, if you see, so the first step would be a user is asking a query. Then the LLM will do the query embedding. And based on query embedding, it will figure out the relevant context Or you can say, I put a question in ChatGPT understand the context is no, okay, this is what is being asked for. Then based on the intelligence of the machine LLM model, it will be going to query our RAG or the embedding database, and it will query based on the context. So context will generate an embedding query, and that embedding will go and it will look for the stores embedding for efficient retrieval. It means one, at the very prerequisite, when you have saved the data in our database, and when we are asking the question, it's again generating the embedding, and based on that embedding value in the n-dimensional space gets the response. Now, if you see here in that Medium article, I mentioned all the steps that are being used here. There is a complete example as well. So in the next continuation video, we'll be covering through the whole code, how it works. If you see here, this will be covering the next session, but for a quick walkthrough, I can tell we are going to cover, say, we have got the annual report from the Tata Consultancy Services, and we have created the embedding for same. And after creating the embeddings, how the embedding looks like, it's like a numerical representation you see here. Suppose that once this is done, and now user want, okay, I need to have some particular response, I need to know the answer for a query. One option, the classical option he has, he can go to that PDF and he can control F and look for the words that he intending to see, and then capture all those responses and then analyze it further and see, okay, this is the response I was looking for. Then it won't be reliable as, because it depends on the user interpretation, manual intervention, how he interprets the response. However, using the embedding model, now since we have created the embedding, a person comes and he says, okay, I need to, like you, can you, the end user is asking through a prompt for saying, please summarize overview of the funds invested. So the system where we are referring, like user asking for the LLM model, it's getting the context. Okay, a person is something is asking, is looking for an overview on the investment of the funds. So based on that, it gets the context, and based on the context, it creates a embedding, and the embedding will be one of the value or a very close value to either of these embeddings, and it will give us the response. Now, if you see, when we get the response, we have got the response of different level of confidence that we refer by score. So here I got the response. For this question, I got a review. One review I got, the PP factor has been sourced from IMF database. This is one summary. This looks very precise with the score 0.08. One is 0.05. This is also good enough, but this is something, it might cover some of the data that might not be of interest for the end user. But we still have a provision. Though there also it needs a manual intervention, which one our user intend to do, but at least it's not missing the most relevant context. However, the maximum the score we're seeing means this is a very precise summary that will be acceptable. However, if the user want it to be more detailed one, he can get it this way as well. More detailed with the numbers, or maybe the one where he got another interpretation, what percentage of total procurement. This is in a different context. So this all depends on the query expansion that will be talking in the next video. This all for now. We'll be covering this code in the next forthcoming session on the video that I'll be creating for the RAG implementation in local system or at the CPU. Thanks for being on the channel. Thank you.